and our producer, Annette Bubak, who will be capturing the show live for Facebook Live. Facebook Live audience, you are welcome to write in and ask any questions. If our listeners have any questions for Tiffany, Sean, or Stan, our call-in number is 702-257-5396. That's 702-257-KDWN. Today our focus is on HVAC equipment, residential service, and what's new in the latest and greatest of air conditioning equipment. Good morning, everybody.
Good morning.
Sean's going to start out and tell us a little bit about HVAC. First off, Sean, tell us, what does HVAC mean?
HVAC stands for heating, ventilation, and air conditioning. Heating, of course, would be wintertime, heating your homes, also heating hot water heaters. Ventilation, bringing fresh air into the house, properly moving air around the home to keep the house cool and comfortable. And then, of course, air conditioning, which we all love and care very much for in the summertime. In what we do, we cover all aspects of that area inside the home to make sure that the houses are heating and cooling properly, efficiently, and correctly.
So we're going to address predominantly residential air conditioning and heating equipment and the service of that.
Correct.
And new equipment and what have you. So give us a little bit of history on air conditioning. Where's it come from? Since I know back in the 60s, when I grew up, we didn't have air conditioning. So I don't know how that worked out here in the desert, but tell us a little bit about that.
Well, before the 60s, people used to hang wet towels in the windows, and that would be considered our air conditioning. Nowadays, we have, our standard air conditioning, which is that air conditioning, that noisy air conditioning on the side of the house that turns on, and sometimes thuds when it turns on and makes that, loud humming noise. The new systems nowadays have gotten much quieter, much more efficient, using a lot less power to do the exact same job that those systems in the 1960s did. They now speed up and slow down depending on if they're, need more power and need less power instead of always using the same power as they did in the 60s. That way we're able to be green, use less power, and still be able to maintain comfort and, cooling inside the home. So.
You had me at wet towel in the window.
Sorry.
How does that work?
You get that nice cool breeze that's blowing through the house. You open one window at one side and the window at the other, and then let that wind blow through the wet towel and give you nice cool air in the house. That was way back when. It's kind of like having a sweaty shirt in the breeze.
So I actually remember visiting in California when I was a kid in the 50s, and they had something called evaporative cooling.
Correct.
So that's what the wet towel is all about. And
Yes.
They had a big screen that would bring water up, and as the heat would go across the water, it evaporates the water, it takes the heat out of the air in order to evaporate the water. We'll get too deep into physics if I tell you how that really works. And that created a little cool air that blew in there. The problem is it increases the humidity greatly. In the desert, that's not a huge problem, but in places like California or the Midwest, that is a problem.
Yes.
So tell us a little bit about some of the innovations that have occurred over the last 10, 15 decades that have improved the efficiency of air conditioning equipment.
Well, one of the nice things is the systems being able to speed up and slow down. They're much smarter systems nowadays, running algorithms and calculations on the backside of the control boards to make sure that instead of running at 100% all the time like our standard air conditioning systems did, or back when the air conditioning was created in the 1960s, where they're running 100% all the time, now we're using what's called custom comfort technology to where it's only running at what it needs to help maintain temperature in that house, but also only use the power that it's needed. It's kind of like having cruise control on your car going up and down hills. The car will automatically speed up and slow down depending on what it needs to do.
Excellent. So electronics has helped a lot.
Correct.
And varying the speed of the compressors.
Correct.
And the fans as well.
The fans, the compressors, yeah, all that stuff.
And so how important is the home envelope in all of this, and meaning the house itself, the windows, the doors,
yeah,
roof? Tell us about that.
The ductwork, the insulation, it's a huge factor. Anytime we look at a system, a new system for a home, we always want to make sure that it's sized properly. If you look and putting a new system in the house and it's either undersized or oversized, of course undersized, it's not going to be working properly. If it's oversized, well, yeah, it's going to maintain temperature in that house, but it's using a lot more power to do the exact same job a smaller system would do. You're wasting electricity. You're not being energy efficient.
So you talk about sizing. What are the metrics we use for sizing?
There's a lot of calculations that go into that. You've got windows, insulation, doors, direction of the house. the square footage, the height of the ceilings. There's a ton of different calculations that go into that. The exterior walls that are actually exposed and not exposed due to overhangs or patio coverings, well, that will all affect the heat load and the envelope of the home. And so anytime we start looking at upgrading a system, we always want to factor that in, so that way we're giving you the best, greenest efficiency system for the home that you're looking for. So
well, I've heard this term tonnage, and they say you need a 5-ton unit or a 10-ton unit. I think that's pretty heavy. How does that work out?
The tonnage is based off of the cooling capacity. The tonnage is 2-ton, or tonnage is going to be covering the square footage of the different houses, the heating and cooling loads of what's actually needed to keep the house.
What's a typical tonnage for, say, a 2,000 square foot home? 2,000's
going to be typically somewhere around a 4-ton system.
4-ton.
So, and that's depending on how the envelope of the home is built, the windows, the insulation, how well everything's sealed. Sometimes you can actually get down to where you only need a 3-ton versus a 4-ton, whereas the 3-ton is going to use less power to do the exact same job a 4-ton does, and that's really where coming in and doing the calculations to make sure that the system's sized properly is the biggest and most important part.
So what's important is the air conditioning unit should run as much as possible as opposed to starting and stopping. So if you have a larger unit, it's going to start and stop more often.
Yeah.
And a unit that's properly sized will run the right amount of time, have less starting and stopping, so it's going to last longer.
Correct.
So having your system sized correctly is a very important thing. We'll talk about this a little bit more when we come back. We're going to hear from our sponsors now. We'll be back with Shades of Green in a minute.